Hi, good morning.
Good morning, Professor.
Hi, how are you?
I'm doing very well. How about yourself?
Oh, pretty good. Yeah, I'm glad that we're gonna have an orientation today so we can introduce everyone. Can you tell me about yourself?
My name's Justin Prochi. I contacted you a few weeks ago about the book for the class.
Yeah,
I work as an engineer at Amgen. It's a pharmaceutical company. I help design small-scale automation for their laboratories. I work with
yeah,
liquid handling primarily, but I don't have an engineering degree. My bachelor's is in mathematics, and I've got a master's in bioscience. It was a business biotechnology degree. So. Um, So I was just interested, and just kind of curiosity led me back to school. So
yeah. Well, great. Welcome, welcome. I think you're gonna enjoy this class. It's the heart of engineering and mechanical design. And it may require a little bit of catching up, in your case, on some of the strength of materials background.
I did take, because it wasn't required for the track that I'm taking, but I did take the 156A, the advanced strength of materials. That's the first class I took, and then I did take the FEM course in the 2 quarters ago.
Yeah,
So I did take those, even though they weren't strictly required, just to try to get my foundation there, and I did well in those classes.
yeah,
But
yeah. Okay.
yeah, it's just, you're right. I learn quickly.
Yeah.
I'll do my best to keep up.
Yeah, it's kind of hard to work full time and go to school, but I think it's a great way to actually get your degree. And what I'm thinking is that since you took 156A and the finite element class, you should have no problem because these are kind of basis for the course. So it should be more fun.
Yeah, and I took them too, just to make sure that I could actually handle it. So
Good.
I figured if I'm going to have trouble with it, I might as well have trouble with it as quickly as possible.
No, this is great. Yeah, so you did the right thing. We're just waiting until everybody kind of comes in, and I'm hoping that we can have these regular meetings every week in addition to the class videos. So today I'm going to just describe kind of the general class contents and the grading scheme and the project and what is expected and the timing and release of material and so forth. So we'll just wait for a little bit until we find a few more people joining in.
Fantastic.
Okay. All right. So just let's wait for a while, and then I'll come back here.
All right.
Okay. So in the meantime, I'm gonna have my coffee. Yeah, I had a late start this morning.
Hi, good morning, Professor.
Hi, good morning.
Good morning.
Hi, Yue, how are you?
Good. How are you?
Pretty good. Okay. All right, so we might as well just start. So I'm going to try to, I'm kind of learning how to use this system. This is a new system called Zoom, which allows for online meetings. And I'm trying to kind of learn it as we go by. So what I'll do is I'm going to try to share the screen here. Okay, so share the screen. Do you know how to share the screen on here?
I think there is an icon, so you can click on it
On the
on the bottom. at the bottom of the screen. So now I'm sharing my screen, right?
Okay, so how did you share it? Can you show me? Since you have your
But
screen.
if I need to stop it and show you. So at the bottom of the screen, can you see the share screen, chat, record, and the invite?
I don't know. I have the can you say again where where is it on the screen?
At the bottom of the screen.
At the bottom of the screen. I don't
Yeah.
have on the bottom of the screen this icon, so I'm not sure where to find it. If you could just share your screen and show me on your screen where this icon.
But once I shared my screen, that icon will disappear.
Okay.
Yeah.
All right. So you guys just give me a little bit of time to figure it out then. Oh, share the screen. I found it. Yeah. All right.
Yeah.
I got it. Yeah. So I think you can see my screen now, right?
Yes.
Okay. So can everybody see my screen?
Yes.
All right, so let's start. I think I just wanted to give a general orientation of the class for the class, and this is recorded. I thought that Saturday morning would be a convenient time for everybody because I know people are working. But I got a couple of emails that people wanted to kind of review the material, record it. So it will be recorded and will be put online. So the class, as you've seen already from the description on the website, it is dedicated to understanding the role of material failure in mechanical design. And it is based on a combination of understanding of material properties to some degree, not a great degree, but it's more qualitative understanding of material properties, and to a greater degree on the strength of materials approach that includes understanding of stress and strain and relationship between stress and strain and deflection. And then the course is heavily applied, so it will be applied towards mechanical components. So the course is going to be, we have lectures online, and the lectures online, once you go to the class website, which you can see here on my screen. Let me just talk about the timing for the lectures. So the lectures, we try to have them timed on a regular schedule, so you are following the class material and you kind of put that in your calendar that every Tuesday and Thursday at 10 a.m. The material will be available for you, and the class material is going to be in the form of short videos. So the lecture might be composed of 2 to 4 segments that are recorded. And in addition to that, we have also PowerPoint presentations that go with with this particular segment that you see online. So that's Tuesday and Thursday at 10 a.m. And then on Thursday, the homework assignment will be released at 10 a.m. So you finish the lecture, and then you'll be able to download the homework assignment and start working on it. And then you'll have a full week, 7 days to finish the homework assignment. and then you will be turning it in on the following Thursday, 1 week later, at midnight. So you have like a week and 12 hours roughly to finish the homework assignment. Once you finish the homework assignment, the solutions will be released online and will be available Friday morning. So that's as far as the timing of the lecture is concerned. Then we would follow that up with online efforts, group efforts. First one is going to be a regular meeting online with me as an office hour, similar to what we're doing right now. And that will be every Saturday morning at 10 a.m. So we'll just delay to 10 a.m. Today we started at 9 because the first time, but every Saturday we'll have a meeting like this at 10 a.m. So in this meeting, it will be free for all. I give a little bit of a quick review of the material because I don't repeat all of the information, but I just give like a quick review of the key points in the week, and then for roughly 20 minutes to 30 minutes. And then I hope that you'll be prepared with questions on the homework assignments and also on the project, because that's going to be an important part of the course. So once I do that, I'm done with my homework, with my office hours, but you can reach me by email. If you cannot make it to the office hour, you can, and the office hour will be also recorded for those who are who don't have time conflicts. And I think the software is very advanced, so you can actually watch it on your iPad or iPhone or at any downtime that you have during the week. Then we have, the class requires a lot of practice, and practice in two respects. One is knowing how to think about solving problems, and the other one is how to formulate and work on a project and implement it to completion. So for that, we have a teaching assistant. His name is Yui Huang. He's right here with us today. And he is a PhD student. He's specialized in manufacturing and design. That's his major field. And he took the course. He did extremely well. And he's also my PhD student working in my group on mechanical design, potentially of high temperature composite materials or failure assessment of materials. So he has quite a bit of experience in more practical things like SolidWorks and COMSOL and Abacus. So all of these tools that we would like to acquire as knowledge base from the class. So he will have one office hour on Friday, and we timed it to be in the evening so that after you work, I know some of you might want to go to the movies or whatever, but on Friday, if you have a chance, you can just spend half an hour, 1 hour to discuss homework assignments and the solutions. That would be great. And then so Friday will be Yui, and then Saturday will be Gonim, and then Monday evening at 7 p.m. would be Yui again, and that would be dedicated to the project. And the project needs guidance, and it needs guidance in terms of the technicalities of how to use computer software, SolidWorks and COMSOL, and eventually also Abacus, and how to implement that in the project. So that will be quite important to interact with him on Monday at 7 p.m. So that's kind of the ideas for the timing of the class material. By the way, you can stop me anytime and let me know if any questions that you have. Okay. So if you go to the class website, on the sidebar, you see, of course, the online meetings here that you're familiar with it because you came to that site here, part here. we have description of the project, and the project is two parts. We would require a progress report, and then we would require a final project report. The project is going to be on the design of a connecting rod of an internal combustion engine. It's an example of a mechanical component that is available for us. Have a lot of literature on it, and there's quite a bit of research on the connecting rod. And it has a lot of interesting design features that would give us good practice, including how to analyze dynamic forces, how to include the pressure forces on the connecting rod, how to optimize it, how to select the material, and then how to do a three-dimensional model for the connecting rod, and then how to analyze it for failure, because that's kind of the key aspect of the course. And then we go through optimization based on that. So we have, the project has a folder, and the folder has many different files that you will be familiar with during the course. Some of them are in MATLAB, so you would also brush up on your MATLAB experience. So you see some of the beam analysis.m, so there's a MATLAB file. And some of these files are not completely worked out, so they are done to guide you in practice. So when you use them, you start putting your input, and then you learn by practice how to fill in, and then you eventually be able to write your MATLAB codes that are required for this course. And the MATLAB codes are either to prepare the data, like pre-processing, or they are required to post-process the data and do the failure analysis.
Professor, a quick question for you.
Yes.
Are we going to have access to all this software by remoting into the system somehow?
Yeah, that's a good question. Because you're enrolled in the course and you paid actually for that course a lot of money, then we request from the university to give us access to licensed software. So I did request already, I put a request that we would have access to MATLAB, SolidWorks, COMSOL, and Abacus. These are the four big pieces of software that are very important for engineering design, and you'll be able to actually access all of these. So the access is going to be by remote logging on to the CNET, and UE will give you instructions on how to access the software, and then you'll be able to use the computer. Once you use the computer, then it will be like the software is like sitting on your own desktop. It's exactly the same, but there might be a little bit delay time in transferring the data back and forth, but in terms of computations, it's pretty fast. So you'll be able to use that. So going back, beyond the software, we have a project manual, and the manual is quite extensive, and it goes step by step. Let me just maybe show you here. If I can project, yes. Yeah, so I wanted to show you quickly the manual. So if you see here, the manual is very well prepared, and it is divided into chapters. Like, for example, this coming week, You look at chapter 1, introduction. It tells you about the software, how to obtain it, and the grading and so forth. And then we go into load analysis. That's the first step in design. And then we do preliminary design using beam theory, similar to 156A. And then we do 2D analysis using COMSOL, which is a finite element software, and optimize everything in COMSOL, so chapter 5. And then we apply failure theories that we learn. So we apply failure theory of fatigue. We have fatigue failure is a big part of the analysis. And then we have to analyze also the connecting rod for fracture. And once we do that, then we can optimize the design and in 2D, because the optimization in 3D is kind of intensive, and it will be time consuming. So we will just focus on 2D optimization. Once the design is optimized, then we take that and do a 3D model in SolidWorks. And the 3D model, you have two options. One option is to use a COMSOL, which is also very powerful. So you can analyze a 3D design in COMSOL or in Abaqus. So I would like you to gain, it's up to you. I think it's a great experience if you could also learn Abaqus, because by the end of this course, you will have the major engineering software that is in the industry. So we have the last chapter is using Abaqus, but if you cannot, if for some reason you don't have the time to learn Abaqus or run out of time, then you could use COMSOL to do the 3D optimization analysis for the connecting rod. So this is on the project. Now, if I want to go back and then talk about the subject material that we have, as you see here, the first lecture is introduction, which is going to be this Tuesday, and this is followed by 2 lectures, one on Thursday and one on the following Tuesday. These 2 lectures are on material selection, and that's a big chapter in the book. I think I sent you information on the textbook. And the textbook that we have is a textbook by Shigley. So it is Shigley's Mechanical Engineering Design. And this book has been the mainstay of mechanical design education for the last half century. So since I was in school, everybody around the world learned from that book. So there are other competing books, but this has been updated many, many times, and it is our class textbook. So the edition that we're going to use, we will use either 9th edition or 10th edition. Since I have 9th edition available to me, then I'm going to assign the homework assignments from 9th edition. But for those of you who are going to get the 10th edition, we will have the statement of the problems for the homework assignments also available. So it doesn't matter whether you have the 9th or the 10th, the differences are very, very small. So this is the book. And if you look at the book, you'll see that it is divided into sections. The section 1 is basics, and the basics are intro to the design, materials, stress, and deflection. So this is the basics. So essentially, the first 2 lectures, materials, is maybe new things that you will learn, but more qualitative, important qualitative information, behavior of material, classifications, types, properties. And as we know all of that, we'll be able to be effective design engineers to selecting the right material for the right job. And then the next two chapters, one on stress and the other one is on deflection. And those are very, very dense because most of you have taken 156A or equivalent, and that's the strength of materials. And the difference is that in the strength of materials course, we go to the basic fundamentals. So we describe derivations of equilibrium, derivation of compatibility equations, solution of boundary value problems, that kind of stuff. Here, we just go right to the applications. So the derivations are extremely minimal, if any, but all of the formulas that are required for analyzing stresses and deformation in components and mechanical components are given in these two chapters. So once we emerge from the first 4 lectures or 4 chapters, then we go to the one of the core aspects of the course, and that's the failure prevention. And we focus on 2 things: static loading, what happens under static loading, and talk about failure due to plastic deformation, failure due to fracture. And then we go on to failure due to variable loading, and that is fatigue, because fatigue failure represents a very significant fraction of all failures of mechanical components. So now we have very good knowledge in stress, strain, deflection, failure, material selection. Then we start applying. And the course title is descriptive of the application. The application is one of the fundamental applications of mechanical engineering. Is called power transmission systems. That's in everything that moves, from automotive to aircraft to all kinds of machineries, robotics, everything has to have, you have to transmit power from point A to point B. And the power requires a number of components, many components, in fact. So what we do is we focus on, we cannot cover all the components in power transmission. So we focus on the key components. So you see that this chapter 7 will cover in shafts and shaft components. That's an important element. And then we skip chapter 8 through 12. That's screws and fasteners, welding, mechanical springs, all the way to chapter 12. Reason is that the analysis of these components is quite simple. And then number 2, they are covered in our mechanical engineering, senior mechanical engineering design class, 162D, at a basic level. So we don't go through those. Then we go through gearing, and the gearing we have chapter 13, 14, and 15. So the gearing will be a key part that we will attach the gears to the shafts to transmit power, either inline or offline, or or gear trains, or many different configurations that we will learn. Once we've done that, then the final punchline is going to come, and that is chapter 18. And chapter 18 is a power transmission case study. So in the case study is going to be designing a whole power transmission system, including the shafts, the bearings, the gears, the housing assembly, and optimizing the entire system. So it's like a gearbox. And in some cases, when I was teaching this class at UCLA, we had interest in more applied side. So we had the students actually make projects and machine gearboxes, and then they would compete for the precision and for performance of the gearboxes. But that's extra effort, and it's not possible with the online part of the course. So what we do is we will give you an open-ended homework assignment, essentially running through the last 3 weeks. And the homework assignment is a project. It's like a mini project. And that is to go through the optimization following the example given in chapter 18. So if you look at chapter 18, you see an example that goes through an optimization of a gearbox, and then you will do something similar but with different requirements, design requirements. So that's the end of the class. You'll see also that there is some analytical tools that would be required, like finite element analysis. This is kind of the icing on the cake. We don't really require that you go deep into the fundamentals of finite elements, but we would like you to be more of a practitioner and learn the tools of finite element and how to analyze the data that results from the finite element codes. I have put together a very short tutorial on finite elements also, and that is optional. So you'll see it when the time comes. You'll see a tutorial on finite elements, and it has a computer program that I described, but this is for those of you who really want to go more into advanced design. Then you can pursue this section. So this is what I have now on the. I go back to the course schedule. So we have covered now the lectures and material selection, and then we get we up to July 2nd, load and stress analysis. We have 2 lectures on July 2nd, July 7th. And then we finished, this would be chapter 3, and then chapter 4 would be deflection and stiffness, 2 lectures. So as I said, these are going to be dense, so they require you to really focus to gather all of the information on stress, strain, and deflection. Then I have 2 lectures that are given, lecture 8 and 9, excuse me, on finite element basics and use of COMSOL multi-physics design. And that's kind of an emerging field, how to use multi-physics combined. So how to combine thermal and mechanical and fluids and so forth. So I'll give some introduction to this field, and for those of you who will continue and take my course 296B, it will be more dedicated to multi-physics in the future. But for this course, I will teach you about basics of finite elements, basics of COMSOL, many case studies. I have several videos, maybe 5 or 6 videos on COMSOL. And then, as I said, Yui is very, very familiar, and then he will fill in and work with you until you get great experience in the technical parts of the software. Then we go into static failure, and then we have a midterm. This is rough. I put it July 26th, but that can change because I'm not sure. I looked at the website and they haven't determined yet the timing for the midterm and the final. So the dates for the midterm and the final may be a little bit different as we get updated from the online website. So having gone through the midterm, then we go into the failure part, fatigue and static failure. And then the last few lectures are going to be on the design of power transmission shafting using a mini project as a focus of these lectures and implementing it up to lecture 18. Then I have a review on lecture 19, and then you find the final exam. The grading for the course, we have approximately 7, could be 8, depends, but 7 to 8 homework assignments. Maybe the last one, it could be, if it is 7, then the last one might be a little bit longer, and the last one is going to be this mini project on the power transmission system itself, the design of the whole system. So that's 10%, and then the midterm is going to be 20%, and in the midterm, you would be allowed to bring in summary sheets that you self-write, so it would be nice as you study to summarize the material, summarize the equations. You'll notice that there is going to be a substantial number of equations, design equations, that will accumulate towards the end of the course. So as you just study, you can summarize those and use them in sheets. Like we'll give you 2 sheets that you can write on them and use them for the midterm and the final. And then we have the project is going to be 30%, and the 30% is divided into 2 parts. One is a progress report, and then the which is, I believe, is 3 out of 10, and then the final report is 7 out of 10, and the 10 would be equivalent to 30%. So you'll get feedback on the progress report, and I have a template to help you write the progress report. So you download the template, and then you put in your own information, own analysis, and own words into it, and fill it up. So we have kind of uniformity of the submitted reports. Any questions so far? I guess we talked about the project and the course. Yeah. So now the lecture notes, you will see the lecture slides are going to look like this. So there will be lecture slides from straight from the book. So if you have the book, you will see the material twice, but the lecture slides, they kind of summarize. So they give examples, we go through examples and develop solutions to these examples, and that's the way it's going to look as we see it. So you will have these slides available, and then you will have the videos that online that you will see. Are there any questions? Okay, let me see. Anything else? Okay, so let's say if I go to week 1, then you will see that I have material in here. This is the lecture slides. That's something similar to what I've shown you. And then you have icons like this course overview, this a video, and then you have the chapters. I have chapters 1 and 2, and the reason I put chapters 1 and 2 of Shigley under limited permission is that I noticed at the beginning of the course some students do not have the time to buy the book. So they would ask to give material until they buy the book. So I have chapter 1 and 2 kind of to get things started, and we don't have to wait until we buy the book. but the material will be available here. Then if you see, you have now these are the course material, introduction, and then you have something like this. So it's labeled 1.1, 1.2, 1.3. It means this is lecture 1. 2.1, 2.2, this is lecture 2 in different segments. And if you go there, you see that this is on YouTube.
Did you know that DirecTV has 99% signal
This is not my
reliability?
doing.
But don't just take my word for it.
I think they
Take it
like
straight-
my videos, so they put.
Well,
They
in this
put-
lecture, I'm going to discuss
So you see me like
things
that,
about material testing.
and then
So
I'll be
follow
on the
chapter
side,
2 of,
and then I have like a screen
by
here,
Shibri.
very advanced
And
method.
what we
And then I'll
would
be
like to
writing on the
cover
screen
today
and talking to you, and
is the tensile
you
test.
see like here, just show you.
Load increases,
So I'm writing
then the
like
stress will
here's
increase.
a stress
And
strain.
then
So it's
finally
like
the material is
exactly
going to
like you're going
expand,
into class,
extend,
and it's a little bit
become
even
weaker,
better because in
and
class
then
you don't see
eventually
really
it will fail.
the
So
blackboard
this is
very well,
Sigma,
but here you will
and
see many different things that are much more
200,000
better.
delta L over L is
So this is
200,000.
the method
Define the yield volume.
that I'll use.
If we look at this curve a little bit more carefully,
so it's
we'll
all
see
in,
that
on YouTube, because I have a YouTube channel myself, and it has a lot of these design things that you will use. And then the assignment is right here. So if you click assignment, you can download it and actually upload your solutions. By the way, you have to make your solutions by hand, whatever, and then you can take a picture by your iPhone or scan it and then upload it, and you will be grading it, and you can see the grades right here. So on this item here, and then we have the solutions will be posted right there, and you can see the release date is right here. Then other things that I wanted to show you is the project. So if you go to the project now, it has, you see videos, project part 1, part 2, part 3, 4, 5, 6, 7. And there's timed release date, so you don't get overwhelmed, because if they're all released at the same time, then you don't know which comes first. So this is like, you're encouraged to actually review those in the proper timing, so you build your knowledge as you go on. And then I have videos for training. So you have training for COMSOL, part 1, part 2, part 3. And if you click on any one of those, again, you get the COMSOL like here. I think, yeah, I'm supposed to be doing something here. So you get a lecture.
Second part of our tutorial on the mechanical wrench, as we
So you see me
remember,
like
we
it's
had
it's
the geometry
pretty nice
defined,
because
and
you
then
actually
we were
I
able
open
to,
up the software
control,
console right here,
some of the bounding
and
conditions of
I
the
put in
mechanical
like a
wrench.
mechanical
We,
wrench,
in fact,
and then I
introduced one
talk to you
bounding
about how to
condition,
click,
and that is
what kind of
here,
items in here on the
bounding
side,
condition
and
on,
how to practice, doing the
this surface
demonstration for the
and
different
we
aspects, like
use
the
this as
solutions
fixed
that you have.
displacement bounding.
So it
This
gives you
divided
like
parameter is one
immediate training
we're gonna describe it
and
as
how to put in the
divided
parameters and so forth.
parameter.
So I think, in my mind, maybe this method of teaching
And
is even better
what is it
than
going
the
to
class
divide?
teaching,
Divide is going to
because
divide
it's immediate. You can
the
just go
average
directly to
mesh
the
size.
subject and
so the
learn
mesh
in a
average
practical way.
is has
think I need to stop it.
basically we have pyramids, 3-dimensional pyramids. So they have some height.
Yeah. Okay, so I think this is pretty much everything that I wanted to cover in this orientation session. Any questions or comments, things that you would like to see?
Nothing that I can think of here.
Okay. All right. So again, I'd like to welcome all of you, and I think you're going to have a great experience with mechanical design. You'll learn a lot, and we'll go from there. So we'll see you next Saturday. Okay. Yeah. Bye-bye.
Thank you.
Bye.
You.